Now in this video we'll see the configuration of IP PIM dense mode. Now before we go ahead, let's try to quickly revise some of the dense mode concepts. Now dense mode uses something called flood and prune behavior, where all the routers initially flood out the multicast traffic or the multicast packets out of all the multicast interfaces. Now if the downstream router does not have any user who needs a multicast traffic, it's going to send something called prune message. Like in this example here, if I take the example, the server is going to send out the multicast traffic out of all the interfaces, and if this particular router do not have any receiver, it's going to simply send a special message called prune that it doesn't want to receive the multicast traffic. Now based on that, it is going to stop the multicast traffic on this particular interface. Now if you have a receiver, probably it's going to receive the multicast traffic on that particular interface. Now the upstream router will exclude the interface from the output list. Now, normally once you receive the prune message, what this router will do is this router is going to remove this particular interface from the outgoing interface, so that it's not going to send the multicast traffic on the interface connecting between these two routers. Now PIM is going to work fine in the small networks if you have a very few users, but it has some scalability issues, like every prune interface is going to expire in every 3 minutes. Like generally when it is sending a prune message, it's going to expire for 3 minutes by default, and the flooding on this interface will resume again, and if you want to stop again, it has to send the prune message again and again. Now this is something periodically flooding and pruning behavior makes the dense mode not really scalable. Now probably in this section we'll practically verify how it's going to work. Now the configuration is going to be straightforward on all the routers. Now this is the topology which I'm going to use for verifying. On the router 1, 2, 3, 4, we are going to enable IP multicast routing. That's something what we are going to do first. And then we need to go to each and every interface which is connected. Like on the router 1, I want to ensure that it should send multicast traffic on these two interfaces, as well as I have some users in the LAN who are receiving the multicast traffic. So I'm going to enable on all the LAN and the WAN interfaces. Now to enable, we just need to add this command IP PIM dense mode, and the same thing on S1 by 0 as well as S1 by 1. Now once we configure this command, you will see the neighborship between the router 1 and router 2. Like we can verify with show IP PIM neighbors. They will use some special multicast address to listen their hello messages. It's going to send the hello message on 224.0.0.0.13, and there is a periodical hello messages for every 30 seconds, and the default timer, a dead timer, will be 90 seconds. And we can verify this PIM neighbors by using show IP PIM neighbors command. So that's something what we are going to verify here. So let's get into the command line to verify the same. So I got my routers pre-configured according to the topology here. Now I can see the topology here. I got my routers, router 1, 2, 3, 4, 5. Now on all these routers I have configured IGP already, and I'm using OSPF protocol as an IGP protocol. Now IGP is mandatory to configure because it's not going to use IGP to advertise the multicast routing information, but it is going to do the loop prevention mechanism here in multicast, that is reverse path forwarding check. We'll be discussing that in the next videos. You need to have an IGP table in order to figure out the source as well. So the first thing, I already have the IGP configured here. If you go and verify on the router 2, I got show IP OSPF neighbor. Router 2 is forming the neighborship with router 1 and router 3. And similar way, if I go and check on the router 4, if I give show IP OSPF neighbors, on the router 4 it is forming the neighborship with router 1, router 3 and router 5. So the next thing, if you verify the routing table, I have advertised all the connected interfaces in my diagram. So the next thing, I'm going to configure the dense mode on these routers. So the first thing, I'm going to say IP multicast routing, and then we need to go to the interfaces, and I'm going to enable IP PIM dense mode. We can also use parse mode. Right now we'll go with dense mode, and then interface S1 by 0 IP PIM dense mode. So I got some debug commands enabled already. So interface S1 by, let me check the commands what I configured. On the F0 by 0, S1 by 0, I need to enable on S1 by 1 as well. IP PIM dense mode. Okay, done. So let me copy paste the same commands on the remaining routers. So IP multicast routing on the router 2. On the router 2 also I'm using IP multicast routing, and then interface F0 by 0 dense mode, and what is the other interface? S1 by 1 IPVM dense mode. Now once you configure on both these routers, you can see show IP PIM neighbors. You can see the router 2 and router 1 form the neighbor relationship, and there is one more command we can use, show IP PIM interfaces. It's going to list out what are the interfaces enabled with PIM, the version 2 PIM, and enabled with which mode, dense mode here. And the default query interval is 30 seconds by default. Now similar way, let's go to the remaining routers and quickly finish the configuration here. I got the same interfaces on all the routers, so it's going to make the things easy for us to copy paste the configurations. Now on the router 4 also I got the same interfaces. I got 2 WAN interfaces and 1 LAN interface. Now on the router 4 I got one more interface, S1 by 2 here, you can see. So I need to enable, which is connecting to router 5. And then finally on the router 5, we just got only few interfaces. On the router 5 we got S1 by 0. There's no S1 by 1, so we don't need on this. Now on the router 5 there is only S1 by 0. Now the first thing, we'll try to verify the PIM neighborship. So I'll go to router 4 and I'll say show IP PIM neighbors. Now on the router 4 I should see 3 PIM neighbors. Now one is router 1, router 3 and router 5. Now you can see there are 3 PIM neighbors on these interfaces, and you can see the uptime here. Now they run PIM version 2 by default, and the mode we are using S mode here. Now the next thing, we'll come to the DR priority value as well on the broadcast networks. We'll talk about that later on. So when I say show IP PIM interfaces, now show IP PIM interface is a very useful command to confirm whether you have enabled IP PIM dense mode or not. Now on the router 4 I got 4 interfaces, 1 LAN and 3 WAN interfaces, and you can see all the interfaces are listed here. Now the next thing, now this is something we are going to configure on all the routers here. Now the next thing what we are going to do is we are going to simulate a client on the router 5 which is supposed to get a multicast traffic. Now in the real scenarios, you have a computer which is running a multicast application which will automatically send out a query message. Now that is what IGMP report message to the router informing that I want to receive the multicast traffic, and then the router is going to figure out where is the source exactly for that multicast group. Now probably in our routers in this lab, even in your CCI lab exams also, probably we are not running a real multicast application. Instead we are going to this interface F0 by 0 and we'll configure a command called IP IGMP join group, and you can use any of the multicast routers here. Now what this command will do is, this command is going to simulate a host which wants to join the multicast 224.5.5.5 and wants to receive the multicast traffic from this particular group address. Now iOS provide this command is going to designate a group membership on that particular interface, and this command makes the router to behave just like a member of a specific group. But here we don't have a real host which are connected to who wants to receive the multicast traffic. Now it's just a simulation of host who wants to receive the multicast traffic from that particular group address. Now once we configure this command, it's going to simulate the host or the clients, and then we can simulate the server from any one of these routers. We can take any one of these routers. Let's say I have a server here, and here we don't have a real server again here. We try to ping from the router 1 to this multicast group address 224.5.5.5, and if you're able to get a reply, then it's going to confirm that from the router 1 you are able to send out the multicast traffic to this particular host. Now it's going to work with something called flood and prune. It's going to flood out of all the interfaces, and then these routers will automatically they'll prune because they don't have any receiver who wants to receive the multicast traffic. Now that's how we are going to simulate here. And then we'll be using some commands like show IP mroute command to verify the entries. So let's go to the command line on the router 5 where I'm simulating the host or the clients, and it can be any interface. I'm going to use F0x0 interface. Just ensure that that interface is enabled with dense mode or sparse mode. Right now we are using dense mode, and I'm going to say IP IGMP join group command 224.5.5.5. That's a group address. Now once we give this command, if I verify show IP mroute, now in my routing table you can see this entry here added here, but right now we don't have any specific entries. Like you can see, incoming interface is null, and I'm not receiving any multicast traffic for this particular group. And outgoing interface defines OIL, that is outgoing interface list, which defines what are the outgoing interfaces from where this multicast has to be sent. Now what we are going to do is we are going to simulate a server on the router, and we are going to generate a ping request to this multicast group address 224.5.5.5, and then we'll verify the table again. Now from the router 1, if I try to ping 224.5.5.5, I should get a reply here. So you can see the reply is coming. If you want to repeat something like 5 times, 6 times, you can just repeat the ping here. You can see the reply is coming here. The reply is coming from 5.5.5.2, and this is your 5.5.5.2 host, that is router 5 here. Now if you further go and verify the same on the router 5, if I give show IP mroute, now here you will see an entry will be added here 4.4.4.2. Now it's saying that the router 5 users, if they want to receive any multicast traffic for this group, this is what we call as S-G entries, and this is your group address, and it's coming from source, that is router 1, and the router 1 IP address is 4.4.4.2 because this is the shortest path here. Now in fact router 1 is having multiple addresses over there, but it's using 4.4.4.2 because this is the shortest path to reach that particular server. Now if you have any clients who wants to receive the multicast traffic for this particular group, it will be sent to 4.4.4.2 because we are simulating a server over there, but we don't have a real server over there. Now similar way, if you have a real server, it's going to send out a multicast traffic on this router, and then it is going to flood out. So like that, every router will come to know about that particular source. Now here, in order to do that flooding, we are generating a traffic from the router 1 to that particular multicast address. Now similar way, if you go and check on the remaining routers, you will find show IP mroute, let's say on the router 4, and if you want to be specific, you can use show IP mroute 224.5.5.5. If you verify, I got some entries here. Now in these entries, if you observe here, the router 4 is receiving the multicast traffic from 1.1.1.1 and 4.4.4.2, and 1.1.1.1 and 4.4.4.2 are the interfaces of the router 1, and it is receiving on S1 by 1 interface, that's the incoming interface. So it's receiving on this interface the multicast traffic, and it is going to send out on the remaining 2 interfaces. It's going to simply send out of all the remaining 2 interfaces here. That's what it says. And similar way, it is also receiving from S1 by 1, that's the incoming interface, S1 by 1. In fact, it is the same thing, same thing. It's receiving from interface, this interface, and it is sending out of both the interfaces here. Now again, the shortest path, it's going to it's going to build the shortest path 3 again. And then on the router 3 also, if you try to verify show IP mroute, and here also you'll see the same thing here. So let me be specific to 24.5.5.5. It's going to build S-G entries where the source address is 1.1.1.1 and 4.4.4.2, the router 1 addresses of both the interfaces, and it is receiving on S1 by 0 and it is sending out of S1 by 1. So it's receiving on this interface and is sending out on this interface. Now based on the loop prevention mechanism, it is also receiving from here, but it is not using this because of the reverse path forwarding check, and we'll talk about this in our next section more in detail. Now here you can see, once I generate the multicast traffic from here by sending a ping request to 224.5.5.5. It's going to generate, it's going to flood the SKMG entries to all the routers, saying that I'm the one who is sending the multicast traffic for 224.5.5.5. Now all the routers are going to maintain those entries in their own multicast routing tables. And if they have any receiver, probably here, if they have any receiver who wants to receive the multicast traffic, they are simply going to send out to this router. Now here there is no more RP. Initially it is going to flood the traffic, and if they don't have any receivers, probably they are going to send out a prune messages saying that I don't have a receiver here. Probably it's going to prune.